this lesson is on solving formulas. Formulas are general rules for describing relationships between various quantities or variables. The following are some words of advice on solving formulas. First of all, you want to highlight the variable of interest and treat all the other variables just as you would numbers. For example, say you have 2L plus 2W equals P. This is the formula for perimeter, and you want to solve it for length L. So you want L to be treated as if it was X, and the W and the P are just treated as if they were numbers. So if you had an equation that looked like 2x plus 3 equals 6, what would you do first? Right, you're trying to isolate x all on its own, and the rest is following basic algebra steps. So first you would want to subtract the 3 here. So here we're going to subtract the 2w from both sides. That'll leave us with 2 length equals p minus 2w. And then, once you've subtracted, what would you do? Well, you would divide by the 2, or the coefficient by the variable, which in this case is 2, and you're dividing the entire thing by 2. That gives us length is perimeter minus twice width over 2. Now, there are several ways of writing the final answer. You could leave it like this. Doesn't seem like anything else can be simplified. If you're not sure if it can be simplified, you can do one of two things. You could either factor the top and see if the common factor cancels with the bottom, or you could split it into portions like p over 2 minus 2w over 2 and see if anything simplifies within each one. In this case, we've got p over 2 minus the 2's cancel here because that's a multiplication, so that could be written like that as well. Both of those would be correct. Another way to think about it is reversing operations. So think of undoing or reversing the operations that were created to make the equation. So adding would result in subtracting, multiplying would result in dividing, squaring, rooting, and so on. Here's an example. So here you've got the formula for the area of a trapezoid. And we want to just get A by itself, but we have a whole bunch of operations that have been completed here. So we need to peel things away. So the last thing that would have been done here was the division by 2, right? It's A plus B, order of operations, then multiplied by H, and then divided by 2. Last thing that was done was division by 2. So division would be counteracted by multiplication. So let's multiply both sides by 2. And since this is under a long division bar, this is dividing the whole thing by 2, so multiply the whole thing by 2 will cancel it out. So we've got h times a plus b equals 2a. We'll just write it like that. Okay, next step, we still want a by itself. So what do we need to peel away next? Well, the next thing that's last on the outer edge here is multiplication by h. So how do we counteract that? Multiplication will be counteracted with division by h, leaving us with a plus b is equal to 2a over h. And then you just want a by itself, so the last thing that's bothering it is the plus b. To counteract that, we can subtract b from both sides, leaving us with a equals 2a over h minus b. Again, you can write this in several different ways using various properties of simplification, but we can just leave it like that. If you want to combine it, you can get a common denominator such as h, and you can then write it as 2a minus bh over h as well. Another thing to think about is to keep the variable in the numerator. So, for example, if your variable of interest is in the denominator, you want to get it out as soon as possible. So in this case, it's divided by t, so we want to multiply by t to release it. We got rt equals d. Now we can start working away with the other properties, so we can divide by r to get t by itself. So t is d over r, and this is the distance, rate, and time formula. So time is the same as distance divided by rate. And another thing to keep in mind, is to keep the variable in one place. So you could have the variable in various places in your equation. You want to get them all together so that you can combine like terms. So you can think of this as factoring the r, or you can say I'm combining like terms. Either way, you have pi plus 3 times r. It can be written like that. And that way, if you have r by itself, you can then isolate it. But if it's in two places, then it's hard to isolate it, of course. So let's divide by pi plus 3 to get r by itself. And that gives us r equals p over pi plus 3. Now you could also have some applications, so let's take a look at this one example here. You've got standard size copy paper with the width and the length given, 8.5 by 11 standard. And a ream of this paper has 500 sheets, and this is the volume that has been given. So we're going to let x represent the thickness of one sheet, and they want us to write a formula for the volume in terms of width, length, and thickness. So then they want us to solve the formula for x and then evaluate it to find the thickness. This whole part sometimes won't be given in a problem, but here they're just letting you know what the process is. I think in general, if you had this in a life scenario, you would probably do the exact same steps as you're about to see. So volume is usually length times width times height. Now we've got length and width and volume, so let's fill that in. 187 inches cubed. The other ones are in inches, we're good. Length was 11, width was 8.5. Now height will be determined by the number of sheets and the thickness of each sheet. So how many sheets do we have? Well, we have 500 sheets that are x inches thick each. So that there is our height. So now we have a formula, and we can simplify this formula a little bit. We can go 11 times 8.5 times 500 to see that coefficient there. So we've got 46750 x equals 187. So now we want to solve this for x so that we know what the thickness of the paper is. So we just divide by this number. So we've got 187 divided by this big number, and that gives us x equals 0.004 inches, and that's the thickness of the paper.